New. All right, so can you guys see my screen now? Yeah, there. So I think I just got disconnected. Hello guys, can you guys hear me?
Yes, sir.
All right, so ulitin ko lang tong share screen ko. All right, so can you guys see my screen now?
Yes, sir.
All right, so let's just go back, okay, one more time. Please, just a recap, maybe 5 minutes from the positive to negative. So balikan lang natin. So again, clamper, okay. So a clamper is a circuit where it consists of the same with clippers. So it has a diode, it has a resistor, and a voltage input, of course. An additional with clamper is just a capacitor. Okay, so this made it uh, possible to not change the voltage input into the same waveform. So whatever is your voltage input, it is the same waveform with your voltage output. Okay, that is because of the capacitor, right? So what else? And then we have three types of clamper. So we have the positive clamper, and then the negative clamper, and then the clamper with biasing voltage. So when we say positive clamper, so it is like this. So as you can see right here, we have a voltage input from positive to negative, negative to positive, and so on and so forth. It's alternating. Okay. And then here we now have uh, still an AC wave, but it's now shifted into the positive side. So positive clamper circuit. Okay, as you can see, same waveform and then same waveform, just that it's above the ground level. Okay. So this is the positive. So if we have negative clamper, it's just the opposite of it. Okay. So negative clamper is now shifted below the ground level. All right. So once you understand how the positive clamper work, you'll be able to understand how negative clamper work also. Because, you know, as you can see right here, the diode is forward bias or it's pointed downwards, but in positive clamper, okay, it's pointing upward or the uh, cathode is the first one. Okay, so that's the only difference, just the direction of the diode. Okay, so this is very critical. So you must understood the positive number first before understanding negative, or vice versa. So once you've understood how negative number works, you may be able to understand how positive number works also. All right. So let's just go back with positive clumper. So positive clumper, how does it work? So of course, initially, if we have this kind of setup wherein we go with positive half wave first. So as you can see, positive here and then negative here. And then positive to negative and then negative to positive. Then it will make our diode an open circuit. So if it's open circuit, then all of our voltage input will pass through or will be able to pass through our VSOP. All right. So our capacitor will not charge first. So that's why we have this kind of output. So whatever is your voltage input will be our voltage output also, right? So second, during the negative half cycles, as you can see, this one now is negative and then this one is positive. So if this one is negative, our negative now is connected to the negative, positive is connected to the positive. So if that's the case, then we'll be having a closed loop here. So for now, just imagine that this one, or yeah, this diode is an ideal diode. So again, if it's ideal diode, if it's for bias, it will able to pass through current, just completely closed circuit. But if it's open circuit, then it's just completely an open switch. But in here, we have here a forward bias. So this one now is a closed circuit. Okay. So if we have a closed circuit here, so again, the voltages will uh, pass through or will choose the less resistance path. So as you can see right here, this one is less resistance than this one because this one is a resistor. So of course, our voltage will choose here instead of passing here. So our voltage will completely loop on this uh, closed circuit. Okay, it will not pass through our V sub O because of course our voltage right now is, or our voltage from before until right now is wise. They don't want to pass through to the path wherein they'll get uh, voltage drop. So of course they will always choose the lesser resistance. Okay, so since right here, of course it will loop on this side. So if we have a closed circuit, okay, if we have a closed circuit, then that's the time that our capacitor will charge. And then what is the sign again of our capacitor? So as you can see right here, whatever is the sign, let's say if it's negative, then that is also the sign of your capacitor here. So how did we get this negative and positive sign of capacitor? So again, this capacitor will negatively charge, okay, by V sub I, and then it will be positively charged, I mean discharged from this point, okay? So I repeat, this will be negatively charged coming from V sub I, and then it will be positively discharged going to our V sub O, okay? But that is for the leader, okay? So as you can see right here, if we have a negative voltage or negative input, we have a complete zero, okay, or zero voltage output up to the negative peak of the negative voltage, okay. And then once it detects that, you know, it is now losing some voltage in that or in this circuit, let's say -2, -1, and a 0, then that's the only time that our capacitor will discharge its uh, voltage. Okay, so moving on. So we now go back to the positive cycle from here. And then as you can see, we have a negative, we have a charge here of 3 volts. But once it go back to, let's say 0 volts or positive 1, okay, then we now have a power loss because our peak voltage in capacitor is positive 3. So as you can see, positive 1 is lesser than positive 3. So now our capacitor will discharge its remaining voltage. So as you can see, here's the first 3 voltage. Okay, say that one came from the capacitor. And then the remaining one is the voltage coming from our voltage input. Okay, and then as you can see right here, positive now is connected to the negative, and the negative is connected to the positive. So that is why we have this kind of setup, which is an open circuit. Okay, so if you're going to take a look on their signs, so our voltage input has the same sign with the capacitor. So if you're going to take a look on this one, so it will just basically added. Okay, so 3 volts plus 3 volts will pass through our visa rule and then go back here. Okay, so that is why we have like twice of the voltage input, because as always, uh, the value or the voltage of capacitor is the same with, or the V peak of our voltage input, or the maximum voltage of our voltage input. Okay, so if we're going to take a look on this one, we now have a complete swing from 0 volts to 6 volts. So before we only have 3 volts. So yeah. So just a summary for positive clampers. So during the negative, our V sub O is 0. And then the capacitor is being charged. And then at positive, so if we, in here, we now have an open circuit. So capacitor now is being discharged. Okay, so if you're going to use KVL, okay, you'll get this kind of equation. And then just simplify this one, or you can just simply transfer this V sub O. So you will get this kind of equation. Okay, so just do the math, okay, and then you will be able you'll be able to get this kind of output waveform, okay, or you can have this kind of equation. So V sub O is equal twice of V sub I. So why twice of the V sub I? Because as always, okay, as always, V sub I is equal to VMC. Well, this is only the case of positive and negative number. But if it's a bias clamper, then that is now not the same with this one. Okay, not twice anymore. Okay, but sometimes twice minus the bias voltage or twice plus the bias voltage. So depending on the circuit. Okay. So any questions so far up to this point? So feel free to ask some clarifications, while I'm discussing this one. Wala pa naman, sir. None, sir. Okay, so I hope everything is clear. So kapag hindi nyo naintindihan, balik-balikan nyo lang, no? Or pwedeng tanggalin nyo muna to, okay? And then just focus on the circuit. And then just use everything, like, use all the things that you've learned from, the characteristic of the diode, from the clipper, and then apply it here, okay? Because just by simply analyzing this one, what will happen if it's positive cycle? Will my V sub I will pass through V sub O or no? Okay, so just analyze it step by step, okay? And then you must also know the concept of a capacitor. So when will be the right time that our capacitor will be in charge, or when will it discharge? Okay. So once you know those kind of concept, then we'll be having uh, no difficulties in solving this kind of circuit. Okay. So here we have an example for positive bumper circuit. So calculate the V out during the positive and negative cycle. Okay, so it is asking us what is your V sub O during positive and then what is your V sub O during negative. If we have a voltage input of 5 volts, all right? So same circuit. Okay, so remember that. Okay, so you don't need to memorize actually. So just analyze this one. Will this accept positive cycle only or negative cycle only? Okay, so just by looking at this one, as we all know, if we have a negative cycle, then we have a complete closed loop here. So from here, we already know that this one is a positive number. So where do we start? Okay. So we always start wherein the capacitor will charge first. Because as you can see right here, okay, coming from the positive or the summary of positive clumper, here first, okay. So we've started in positive, but nothing happens. Okay, so we still have the same input. So Vi is equal to V out. But our official graph is like this. So it started from the V sub I and then twice now of the V sub I. So it only started right here. Okay. Or during the V peak of the negative cycle, which is negative 3. Okay, so from here to here, and then we now have a complete loop. It's like this. Okay, so again, you must always start with a cycle wherein we are charging the capacitor. Okay, so what polarity is that, or what cycle is that? Is it the positive half cycle or the negative half cycle at this point?
Negative, sir.
Negative. Okay, so this is very simple. So you must just have a closed loop here. Okay, so what is that cycle that will make this a closed loop? So you must have a negative here and then positive here. So negative is connected to the negative and then positive is connected to the positive. So if that's the case, then we now have a closed loop. So again, if it's closed loop, that's the time that our capacitor will be charged. Okay, so once it's charged, then you can now go back to the positive half cycle. Okay, then that's the time that we will start having the correct graph. All right, so here's the solution. So as you can see, we've started from negative or negative. So during the negative half cycle, diode is short circuit. Okay, so we have a closed loop here. So of course, if we have a closed loop here, it will never be able to pass through our V sub O. So V sub O is equal to 0. So capacitor now is being charged. Okay? And then VMC is equal to V sub I. So what is this VMC? VMC is the maximum voltage or peak voltage of the capacitor. So from here, as we can see, VMC is equal to V sub I or V. So V here is a voltage source or VI is a voltage input. So as you can see, we have here a voltage input of 5 volts. So VMC has now a value of 5 volts. Now, if you're going to take a look on this one, we have negative here and then positive. So this is being negatively charged and then it will discharge positively. So that is why we have uh, what do you call this one? A sign of a positive 5 volts. Okay. And then during the positive half cycle, so diode is open circuit and then capacitor now is being discharged. So here's like our always a pattern. So if it's short circuit, capacitor is being charged. If it's open circuit, capacitor is being discharged. So remember that one. That's the very concept when it comes to clamper. Okay. So if you're going to apply KVL, okay, so you will get this kind of equation. Oops. So V sub I plus VMC minus V sub O. Okay. And then you can simplify this one a little bit more. V sub O now is equal to V sub I plus VMC, wherein V sub I is 5 and then VMC is also 5 volts. So 5 plus 5 is equal to 10 volts. Or you can use the other two, wherein it's just twice of the V sub I or twice of the V sub I. So as you all know, V sub I is equal to VMC, so you can do this one. Okay. So all of them have the same result, of course. So 10 volts. So as you can see right here, during the negative, we have V sub O is 0. And then during the positive, then that's time that our capacitor will be discharged. So it is now this one, this part, now being lifted to instant 5 volts. And then our V sub I, another 5 volts. So we now have positive 10 volts. Then, yeah, okay. So as you can see right here, it is now clamped positively. All right. So did you get the idea so far? Okay, so I will wait. So you can guys check this one. So pwede nyo tong titigan. Titigan nyo lang ng 1 minute, 2 minutes. Just analyze it. Okay, so that's a good thing to know that most of you have understand it already. So really hope so. So if my explanation is not enough, okay, so feel free to watch in YouTube. Okay, so I hope just by watching in YouTube and watching my lecture, so you'll be able to understand how a clamper work. Okay, so hanap lang kayo ng magaling na magturo. Okay, mabilis magturo. Okay, because in my case I explain it uh, step by step, like what will happen during this side, this one, blah blah blah. So meron namang ibang ganun din, super detailed and then super galing din. Yung mas magaling pa nga sa akin. Sobrang dami dyan. Okay. Anyway, may clarification ka so you can ask me anytime, okay? Alright, so let's now go to negative clamper circuit. So it's just the opposite of positive clamper wherein we just flip the direction of the diode. So as you can see right here, if we have a positive half cycle, okay, so our uh, circuit now will be completely a closed circuit. So we have a complete loop here. So as you can see, it will never be able to pass through our V sub O. So as a result, it will never, or yeah, V sub O during positive is always 0. Okay. So this is just to show you that we have another kind of waves. So we always use sine wave. Okay. I just would like to show to you guys that we also have square wave and then other kinds of waveform. So mostly we always use sine wave, but we also have square waves, triangle waves, and then sawtooth wave. So of course, all of them have specific functionalities. Like square wave, you want to know the exact point wherein it shifts from positive to negative. Okay, and then for the triangle, you want to know, okay, the peak voltage from positive to negative. And then the sawtooth, you want to know when is or when it shifts from actually this one covers everything also. So you can easily see the half of the positive and easily see the negative half cycle. But in here, it's like we're measuring the peak to peak voltage of from positive to negative. Okay, so that's their uh, main purpose why we have different kinds of waves. All right, so let's now go back with negative clamper. So how does it work? So same functionality, it's just a different sign. Okay, so let's go on to this one first. This one, okay. So as you can see right here, if we have here a closed loop, let's say positive to positive and then negative to negative. So if you're going to take a look on this one, it will be positively charged. Okay, positively charged, and then it will discharge negatively. So if that's the case, then the sign of our C now, okay, a capacitor now, is negative. Okay, so yeah, that's your only difference actually, the sign of the capacitor. And then so let's go here, the negative clamper circuit. Ah, here first. So another example, calculate the V out during the positive and negative cycle, wherein we have a voltage input of 8 volts, right? Okay, so here's the solution for this one. During the positive half cycle, the diode is short circuit. So again, I repeat, you must always start uh, in a cycle wherein we'll be having a short circuit or a closed loop. Because if we have a closed loop, our capacitor now will be charged. So that's the uh, first step that we are looking for. Okay, so as you can see right here, it will be only uh, a short circuit or a closed loop if we have a positive uh, upcycle or a positive loop. Okay? So as you can see right here, diode is short circuit. So as always, if it's short circuit, V sub O is equal to 0 because it will never be able to pass through our V sub O. Oops, okay, interchange that. And then capacitor is now being charged because of that. And then VMC is equal to V sub I, wherein we have a sign of negative 8 volts. So why negative 8? Because again, this one is the being positively charged, and then it will discharge negatively. So positive here and then negative here. Okay. And then during the negative half cycle, so just the opposite of this one. So diode now is open circuit. And then if it's, let's say if we have an open circuit, then capacitor now is being discharged. Okay. So that's the time that it will discharge its voltage. So again, with the use of KVL, so you'll get this kind of equation. And then if you simplify this one further by getting the V sub O, so you will get this equation, V sub I plus VMC. Oops. So V sub I is negative 8. So negative 8 now because we are now in negative half cycle. So negative 8 plus negative 8 for our VMC. Okay. So if you're going to add those two, you'll get negative 16 volts. Or you can have the other two alternative equations like negative twice of the V sub I and then negative twice of the V sub I, which is also the same. So all of them are 16 volts or negative 16 volts. All right. So that's actually it for negative damper circuit. So quite simple once you've able to understand the positive damper step by step. So any clarification or question so far? Answer. Okay. So really hope so that you guys have understood it completely. Hindi lang yung partial. So mas maganda yung buo, di ba? Mag-aaral ka na nga lang, sulitin mo na yung pinakasagad-sagad na. Dapat naintindihan mo talaga. Sayang ang tuition fee. So how about the others? Do you guys have a question or clarification? All right, so answer and answer. And all right, so okay, that's good then. Okay, so let's move on to the next topic. So this is the last kind of clamper. But of course, marami siya. Okay, because we have different kinds of biasing. So for positive clamper, we have positive biasing voltage and then negative biasing voltage. And then for negative clamper, okay, we have positive biasing and then negative biasing. So basically, it's just the polarity of our bias voltage. Okay, so bias voltage is not new to you. Okay, you have already experienced that one with just starting from the half wave, full wave, and with the clipper. Okay, so let's start. So positive clamper with positive biasing. So how will we know if it's positive biasing? So positive come first before the negative. So that's how will we know if it's a positive biasing voltage. So as you can see, this is a positive clamper. Okay, just an additional biasing voltage. So its uh, symbol is V sub R. Okay, or in our previous topic, I called the bias voltage as BB. Okay, bias as in bias voltage, but this one, their bias voltage is V sub R. Okay, so meaning this one is the uh, positive reference, okay, or a positive reference voltage. Okay, so as you can see, the same everything's the same. So positive to negative, negative to positive. So that's our voltage input, right? And then we have the same setup, just additional V sub R. So again, if you're going to analyze this one, we will start on negative half cycle. Okay. No. Sorry. So actually, you can start either of those two. Okay. But my advice is you must always go with a higher uh, voltage, like a higher comparison between those two voltage. Because as you can see, we now have two voltage source. So either of those two can charge the capacitor. So our V sub I has the capability to charge this one. So depending on the voltage of V sub I, and then our bias voltage also has the capability to charge the capacitor. Okay, if our V sub R or our bias voltage is higher than the V sub I. So as always, at some point, okay, our V sub R uh, will be higher than V sub I because as you know, our V sub I is an AC voltage. So it always starts from zero to or up to its maximum voltage. Okay, so at some point, V sub R is higher than V sub I. So if that's the case, so just take a look on this one first. So positive is connected to the positive and the negative is connected to the negative. So as you can see, if that's the case, then we have a closed loop here. During the V sub R is higher than V sub I, wherein V sub R now will charge this capacitor. So the sign of the capacitor now here is it will be it will be positively charged here, and then it will be negatively discharged at this point. And then as you can see, they are contradicting. So they are colliding. V sub I going here and then V sub R going here. So once our V sub I now is greater than V sub R, okay, so our capacitor now will be positively charged and then it will negatively discharge. So if you're going to take a look on this one, at the end, of course, whatever voltage that is higher than that is the dominating voltage. All you need to do is deduct the lesser voltage on the equation. Okay, so you will see later on how those two voltages work with each other. Okay, so for now we will stop right here because we now only have I think 30 seconds. So again, wait 5 to 7 minutes, and then if you have a question, so just wait for the part two. Right. So goodbye for now, and then see you on the part two. Right. So I'll end this one now for now, and see you in part two.